So we're gonna do a review of integration. Okay, so to make sure everybody's in the same page, and I save you some time so you can go to your homework directly. So review of integration. So let's start remembering. So this is really it's called the antiderivative, right? So you need to, what is the integral of x dx? That means what function I write here, and the derivative of that function is going to give me x. So what could be a function? So x squared divided by 2, right? So if I find the derivative of this guy, I'm going to get x, right? But there is more than one. I could have plus 1, plus 2, plus all those, because the derivative of a constant is 0. So usually the formula is plus a constant. Okay? So what is the derivative? So not the derivative, the integral of 1 dx. X. Right? Then what is the integral of s cubed dx? The 4 to the 4 plus c, right? So in general, we have a nice formula, right? Integral of x to the n dx. What is that formula? xn plus 1 divided by n plus 1 plus constant. And you can check it, because the derivative of x to the n plus 1 is, if you find the derivative of this guy, so let me do it here fast. So that will be n plus 1 times x to n plus 1 minus 1, right? The derivative of a constant is 0, and this is divided by n plus 1. So this guy cancels with this guy, and plus 1 with minus 1 gives me x to the n. So the derivative of this guy has to give me this guy, as it just happened. Okay, so that's the relation. And then this is called the fundamental theorem of calculus. The fundamental theorem of calculus says so you spend in high school all that you learn could be reduced to the fundamental theorem of algebra. I will tell you in a second. Well, the fundamental theorem of calculus says that you have the integral of f of x dx between a and b. This is capital F of b minus capital F of a, where the derivative of the capital function is the small function. Okay, and f is nice. F must be differentiable in order to do this. Okay, so that's the fundamental theorem of calculus. So that's basically what we're doing. The derivative of the outside of the capital one gives me the small one. Okay, so let's do more. So let's do the integral of cosine of x. Integral of sine of x. So let's do a little quiz for yourself. So write me in front of this the answer. Integral of cosine, integral of sine, integral of 1 over x. And yeah, just put just those. So what is the antiderivative of cosine? Sine x plus c. Antiderivative of sine of x? Negative cosine of x plus c. And then antiderivative of 1 over x? To log absolute value of x. Okay, that's important, because the logarithm function, it has to have a positive domain. So you cannot evaluate ln of minus 5, for example. Okay, so that's why we put the absolute value. Okay. Okay, so first part. Then we go to the last thing you learned in calculus 1 was integration by substitution. So let's do one integration by substitution. So example, let's do the integral of x plus 3 squared dx. Oh, how do we find that integral? Substitution, yeah. So we do, what do we do? U equals x plus 3, and then we go du equals dx. So let me use colors here. So now not yet. So we substitute. So I got integral, instead of x plus 3, I write u. So I get u squared, and instead of dx, I write du. So what is the idea of substitution? The idea of the substitution is that you reduce this integral to something that you know, as here. You reduce to this table, okay? So those that you already know by memory. That's basically because the definition, by definition of integral. Okay, so you know that one. So what is the integral of u squared? Plus c. But then we are not done, right? So what do we have to do? Substitute back. So it will be x plus 3 cubed divided by 3 plus c. So now you can check. Let's check this. So the derivative of this is 3x plus 3 squared divided by 3 times the derivative of the inside. What is the derivative of the inside? 1. Plus the derivative of constant is 0. So I got 3. So I got x plus 3 squared. So that's exactly correct, right? The derivative of this guy gives me this guy. You see, the derivative of this guy gives me that. So that's exactly what I need to check, because that's the the fundamental theorem calculus. Okay, so that's a substitution technique. So you will do more. We're gonna do now the most famous one, integration by parts. That's gonna be your savior. Also this one. So integration by substitution is gonna be like fundamental for you. Okay, so go and do the review, because you have several substitutions there. The review in Webbook, right, that I did. So another example, we're gonna find the integral of x times e to the x dx. Okay. So let's remember what is integration by parts. So integration by parts you have integrals of u dv. Turns out that you can write this like u times b minus integral of b du. Why is this interesting? Because you see I have u dv here, and I basically switching b du. Okay. So it makes one problem hard in something slightly easier. So that's why it's valuable integration by parts. So we need to make a substitution. So what will be u? U is, we need to choose u and we need to choose dv. So what would you like to have for u? So usually you put for dB, well, no, probably better to explain it this way. Usually you want, let's say you put u, right? So the u will be dx. That's good because it's disappearing. If I put u equals e to the x, then I will get the e to the x. It's still there, so it's not helping. So the ideal integration by part is that things disappear. So that u is going to disappear something. And so I go e to the x dx, and the integration of that one is b, and this is e to the x. Because I need to find the antiderivative of this one. So if e to the x, the antiderivative of e to the x is e to the x. So that's my substitution. So I'm going to place it here. So I got u, I have u db, so this is u db. U db, you see? U db is this guy. So I need to go u times b is this, x times e to the x, minus integral of b du. So b is this guy, du is dx. So my answer is x times e to the x minus e to the x plus a constant, right? Oh, I forgot that one, right? So one of the formulas here is e to the x, right? So integral of e to the x is e to the x. That's also a classical formula. So is this correct? Well, I can verify. So let's verify. Verification. So the derivative of this guy has to give me this guy. Okay, so let's do it. So x times e to the x minus e to the x plus c, the derivative is the following. So what is the derivative of the first one? E to the x. No. So what is the derivative of this one? Product rule. So we have the derivative of the first one is 1 times the second without derivative plus the first one without derivative times the derivative of the second one. The derivative of e to the x is e to the x minus the derivative of the second one. Oh, I'm sorry. What is the derivative of e to the x? E to the x. The derivative of constant is 0. So we get this cancel with this guy, so I got x e to the x. So it's correct or not? Yes. And you can do, that's why calculus is so valuable. Integration. This is a marriage. You do differential equation. Yeah, sorry. You do calculus, then you do integration, and then you have a baby and call it differential equation. So this is the baby. So you guys are getting old. So okay, so we got let me see. Okay, a last one. That's because we're gonna do it a lot of times, and then we can get a little. No, let me give you more time. Let me stop this here.